Good day, class. Welcome again to our another session of differential equation. And right now we are still on the first order, first degree differential equation. And our method to be used is linear differential equation, which is in linear differential equation, you need to transform your general form into your standard form. So you can see here, you transform your general form converted into standard form. Okay. So as we know, the first order first degree differential equation has this general form, m of xy dx plus n of xy dy equals 0. So we will be using two linear differential equations. The first one is linear in y and the other one is linear in x. So the linear in y have this standard form. So the standard form for linear in y is dy over dx plus y p of x equals q of x. So our target here is that our given differential equation will be transformed into this form. So meaning you will have your dy and dx at the leftmost plus you need to have your y, and the remaining here will be your px, and on the other side are your q of x. And these are the things you need to remember when you are doing linear differential equation. The first one is y and dy are the first degree terms. And this next one is the product of y dy does not exist in the standard form. So if we were able to transform your general or your given into this standard form, then we could get our value for our p of x and q of x. In that case, in order for us to solve our general solution, we need to have our q of x here to be substituted, and we have this if. If stands for integrating factor. So integrating factor is to be solved. So in order to solve integrating factor, you need to get the value of your p of x here. So your p of x will be the power of your exponential. So meaning your integrating factor will be equal to e raised to the power of integral p of x dx. Okay. So in the same manner, if we solve linear in x, so the difference is just that the numerator on the leftmost of the equation is dx and the denominator will be dy. So it will be added. So if you could see here, because we use with dx, so this is x, and what remains here is py, and the other side is q of y. So if you could see, so look here and here, the difference is just the variable. So in this case, your qx is in linear x is qy. Your px here, this is py, and this dy over dx and dx over dy. So the same rule. So x and dx are the first degree terms, and the product of x dx does not exist. So we need also to get your px and qx, so that we could substitute it here later on in your general solution. So if you are using linear in x, therefore you will use x here in the general solution multiplied by your integrating factor, which is equivalent to the integral of your qy times integrating factor dy plus c. So where your integrating factor is again the exponential raised to the power of py dy. So here, this is an example. So if you have a form like this, therefore, because the numerator is dy, denominator is dx, and we see here that this is really the standard form of the linear differential equation, then we could say we have y here, we have our p of x and q of x, then we could say that this is linear in y. So the other one is also, we have dx over dy plus x 2 over y, and on the other side, that is all y Therefore, this is linear in x. So let's try first example. So let's try to solve. So, okay. So, let's write first the given. Okay. So let's write first the given. So you have x dy. So, sorry. Let me erase this one. So, okay. So, minus, okay, plus, sorry, that is plus, sorry, plus 3y dx equals 2x cubed minus x raised to the power 4 dx. Okay, let me enlarge this one. Let's try to see if it's correct. Dx dy plus 3y dx equals 2x cubed plus minus x raised to the power 4 dx. Okay. So from here, okay, let's try. Let's start solving. Okay. So from here, our target is to, okay, our target is to make this general form into our standard form. Okay. Transform this into our standard form. Sorry. Standard form. Okay. So, the standard form, we know that, let's look first what is the most easiest. If you use linear in y or linear in x. So, if we could see here, so in this side, we have dx. If we divide dx here, we could cancel the dx in this side and also the dx in this side. And we will have an over of dx. So therefore, if this is easier if we use linear in y. So we will use linear in y. So linear in y. Okay, so we'll be using linear in y. So linear in y, so in this case, we need to divide by dx. So we have dx dy over dx plus 3y dx is equal to 2x, sorry, you have dx here, 2x cubed minus x raised to the power 4 dx over dx. So from here, change the color. So from here, we can now cancel this dx, cancel this one, and this one also. So what remains in our equation is just x dy over dx plus 3y is equivalent to 2x cubed minus x raised to the power 4. But in this case, is this already a standard form of linear in y? Remember, the standard form of linear in y is that you have dx over dy plus y, p of x, then q of x. So if you could look here, so we have still x value. So our target here is to look, we will make this one to be the same in our standard form. So we need to eliminate this one by dividing both sides by x. So by dividing that one, what will remain is dy over dx, because we will be dividing the x, plus 3y over x is equivalent to, divide this one x, so what remains is 2x. So we have cube divided by x minus x raised to the power 4 divided by x. Divided by x. So after that, we have our dy over dx plus, so our target here, we have, diba, we say that we will make this one into a standard form of a linear differential equation in y. So the standard form, we have y here, and we will be targeting our p of x. So we have x here, so y here, so what remains here is 3 over x, right? So y times 3, this is still 3y over x. So we have here 2x squared, divide na siya. So this one, sorry, let me change the color. So here, so cancel this one, this one, this one, and also this one. So from that, so from there, you have x cubed divided by x, you have x squared, times 2, you have 2x squared. So then, deducted by x raised to the power 4 divided by x, you will have x cubed. After that, let me write it here. So from here, we already get the standard form, because if we can recall, the linear in y, the standard form of that is dy over dx. Okay, let me clear this one. Dx plus y, p of x is equal to q of x, right? So this is the standard form. Okay, so there, if you could look at here, you have dy over dx, we have y here, and our p of x is 3 over x, and our q of x is 2x squared minus x cubed. So let's write here. So now we already get the value of p of x, which is 3 over x, and our q of x is equivalent to okay, very good, 2x squared minus x cubed. After that, we have these values, the p of x, we have the p of x and the q, and the q of x. So now we could solve for what we'll be solving next, that is our integrating factor. So our integrating factor. So our integrating factors is equivalent to e raised to the power of integral, because this is linear in x, linear in y. So you have p of x dx. So now your integrating factor is equivalent to e raised to the power, what is our p of x? That is 3 over x dx. And now, solving this one, we can move the constant value 3 outside the integral sign. So therefore, we have integrating factor. We have e raised to the power of 3 integral of dx over x. And we know that integral of dx over x is ln of x. Okay, very good. So we have e3 ln of x. So integrating factor will be equal to e ln of x raised to the power of 3. And we know e raised to the power of ln is equivalent to 1. So now, your final integrating factor is equivalent to x cubed. Okay? So this is your